Hello guys, welcome to my channel Vivek Pandey. So in today's lecture, I'm going to cover this question of a lead code 191. So the question is, let's try to understand what exactly the question is all about. 191, number of 1 bits. So by reading this, what I got to know is we need to find out total number of ones. So let's try it out once, the explanation part here. Now, in order to solve this, first we need to understand what exactly the problem is. Means problem. What is the problem? Whatever the number is given, that number, how many set bits we do have. So set bit means what? How many ones, and unset bit is 0. Okay. So in any number we can convert it into binary. So for example, if I have 5, and I guess that is a very basic things, how to convert it into binary. So how to convert it into binary, like the binary will be 101. Yes. And for the 9 also it is, for 9 how much it is, this is 1001. Yes. So now in this, how many ones are there? Means how many set bits are there? So set bits means 1. So how many are there in 5? It is 2. And then here also it is 2. Yes. And then in the example of a lead code, it is given that 11. For 11, it is 1011. So it is simple. We can go with a base power 2 to the power 0, and then we can calculate. So this is, I guess, everyone knows how to convert it into binary. Okay. And that's it, guys. So here, how many ones are there? uh, Number of ones are 3. So now this is the problem statement, and this is the input, and output is this. So input will be given a number, and in that we need to find out how many set bits are. This is very simple, easy question. And let's try to check it out in how many ways we can solve this. So first approach is simple. We need to what we need to do is convert the number into binary. You have to convert and count the what we have to count the ones. That's it. And second one, we can go with the like modulo and the floor division. Yes. So in this, we are trying to find out the mod operator, the reminder operator, and add it with a count. Means count plus mod operator, means mod of number. So n percentile 2, with the 2 if we are doing, and what would be the reminder that we need to add. And then we have to keep on subtract. Yes, we need to divide it. Yeah. So in order, I guess you know how to divide. So n floor division to, yes, division operator. So that's it, guys. This is the second approach, and the third approach would be like we need to find out if it is odd number. Means how to check whether it is an odd. So yes, we can check something like this: 5. If I have n and 1, that's it. So n and 1 means if it is a n is odd number, definitely it will be a 1. We will be getting 1. If it is odd, if it is even number, then definitely it will be what? 0. So let's see one small example of the third step. In the third step, what happens is, for example, I have taken a 5. 5 binary is 101, and then 1 binary is 001. Okay. Now I'm just applying and. So if I apply and, it will be 0, obviously. 0, 0, and then 1, because the characteristics of a and is what? If everything is true, then only it should be true. So the last one is true, it is 1. So we are just checking. If it is 1, then increase the count. uh, increase Increase the count. That's it, guys. So this is all about the approaches. Third approach, and the fourth approach would be same, but here what we are doing is we are just removing the set bit, right moves set bit. So we are just removing the right moves set bit. And how we can remove? Simple. It is just n and n minus 1, n minus 1. So simple. For example, if we have 5, I'm just trying to update it. Okay. So 5, I what I'm doing is 5 and 4, right? So what is 5 and 4? 5 is what? 101. So 101, and then 4 is 100, And then if I try to perform AND operation, again it will be what? This is 1, this is 0, 0. So this got updated. Updated to what? This got updated to 100, means rightmost set bit has been removed. In the same way, we have to keep on doing, and then we have to we have to reduce it also. So I guess you have understood this four approaches. Now let's try to apply the four approaches on this code, and let's check it out. We'll go with the first approach. First approach, what I said is here. First of all, a return. Yes, because it is a function and I need to return it. And what I need to return means binary. So to convert it into binary directly, we have an inbuilt method. And what is that inbuilt method, guys? Bin of. So I'm just taking bin of what? N and dot count. We have also inbuilt method for a count, and then we are trying to find how many ones are there, because bin is the data type of the bin is what? String str, because it is an alphanumeric 0b101, like this will be getting the output. Okay, so now let's try to execute this and check whether it's working fine or not. So I'm just directly submitting this, and finally it got submitted, guys. It is fine. Now let's go with another approach. The approach what I said is we need to take a counter variable. Okay, here all four approaches I'm just going to execute in front of you. So now here I'm just taking counter, count is equal to 0. And then what I said, we have to count, we need to add the count with a reminder and then keep on reducing it. So how we can do that? I need to do it continuously when the till n becomes 0. So while this, and now what I need to do here is I need to take a count, count, and then is equal to count plus what I'm going to add now, n percentile, the remainder of this by 2. That's it. And once it is done, I need to also reduce this n. So how to reduce this n? We can reduce it in a two ways. N flow reduction equal to 2. That's it. And then return count. And it should also work. Let's check it out whether it's working or not. So I'm just submitting it. Yeah, even this got submitted and it is also working fine. So this is the second approach. Now let's go with the third approach. What is the third approach is? In the third approach, what I said is we are going with the counter. Okay, fine. But in this, we are going to check one condition. What is it? If condition. In if, we are checking what? If it is odd, n, and so and 1. If it is odd, then increase the count, means count plus equal to 1. That's it. And then even this also works, but if we wanted, we can go with the bitwise operators also. But let's check it out whether it's working or not, because we can reduce it with the help of right shift operator. So yes, it is working. And let's go with the right shift once. So in order to go with the right shift, what I need to do here is simply a right shift, because both are same actually, because right shift is used as a division operator and the left shift is used as a multiplication operator. So let's check it out once. Oh my god, it's giving me wrong answer. Let's check it out what happened. So right shift, okay, what is the problem here is right shift two times we are doing. Actually right shift should be what? One time, right? So it should be one time, not a two time. That is the reason we are getting output as one for n for 11. Yeah. So let's execute it once again. Yes, guys, it has accepted. Fine. Now another part was without this. What I said, what we are going to do is n is equal to, we are updating it because we are going to remove the rightmost bit, set bit. So how we are going to do that? N and n minus 1, n minus 1. That's it. And then you can keep on increase the count. Fine. you are keep on increasing the count once it is done. So let's check it out whether it is also working or not. I'm trying to submit this again. Yes, guys, it is submitted. So with this, I have shown you, we have discussed on the four approaches and we have successfully executed all four approaches. Now, a small task for you all. I wanted you to tell me what would be the time complexity in all the cases and which one will be the optimized solution.